Hi, I'm Peyton Kilborn, and this is my lab report for Lab 2, Motion of a Falling Object. The purpose of this lab was to use the velocity update equation and an experiment to understand the motion of an object that is moving in a constant path at a changing velocity due to a net force on the system. And we did this through dropping an object, in my case a ping pong ball, and using Tracker to analyze its position as it's falling. And then we created two GlowScript codes to model its behavior and position. The first model was just factoring in the force of gravity. The second was factoring the force of gravity and the force of drag. And then we combined all three of those into a graph that shows all three positions as a function of time. This experiment had two key ideas. One was using the position and velocity update formulas to predict motion with a constant net force, and the second was the comparison between observed position from Tracker and the predicted positions from GlowScript models, both with and without drag. The relevant equations here. The important one is net force is force of gravity and the force of drag. Force of gravity is the mass times the gravitational acceleration constant, and the force of drag is just proportional to the speed of the object squared. And then the other two are just the position and velocity update formulas. And then for this experiment, we had to make some assumptions. In my case, I just made two. One was that the motion was only in the y direction, and the other one was that the ball was dropped from rest, so no initial velocity. Both of these were made because it makes the numbers easier to apply to the equations, and it makes the GlowScript models more accurately depict what happened in the experiment and respond well to what was seen in Tracker. Here is my Tracker video. We can see the system in this case is just the ping pong ball, and the surroundings are basically everything else. Here are my initial conditions for code. I found the mass of the ball online. The position was given to me by Tracker, assuming velocity is 0. Delta t matches with the frame rate, and the gravitational acceleration constant is g, and b is the constant that just made drag match up well to my data. Here is my code. What's important is line 69 through line 78. That's just rewriting the five equations that I showed earlier into a format that GlowScript recognizes. And then 80 through 83 just updates time. There's a link to my code. Here were the two velocity versus time graphs that GlowScript pointed out. Left one is without drag. It has linear motion because it just has the object keep getting faster and faster as it's falling. The one on the right is with drag. It has parabolic motion because it has the object slowing down as it approaches its terminal velocity. And then here is the comparison between all three of the positions versus time. Blue is from Tracker. Red is from GlowScript without drag. That one always estimates it just a little bit lower because it's not factoring in another force on the system. Yellow is GlowScript with drag. That one is very close because it is factoring in the extra force. And then all three of them have the same general parabolic motion because they're all due to the same acceleration. And then a source of error we could have had is I could have dropped it and maybe pushed it down more, so it could have had not 0 initial velocity, which would affect the data. Or in Tracker, there's motion blur, so maybe I wasn't quite on the center of mass on the ping pong ball. And for the additional understanding questions, if the object was thrown downward, would it affect terminal velocity? No, it would not, because the terminal velocity is proportional to the square of the current speed, they would eventually even out to the same terminal velocity. And for what does it mean? The model that best predicts terminal velocity is the one on the right here from with drag, because there it shows that the object doesn't just continue getting faster and faster, it actually has it slowing down as it's coming into contact with air resistance, which is basically just what drag means. And yeah, thank you for looking at my lab report.